In question 1, we're given the curve with this equation here, and we need to find the y dx, writing our answer in its simplest form. Well, we know that in differentiation, we multiply by the power and we deduct 1 from the power. So we're going to get 2 over 3 times 3x squared minus 7 over 2 times 2x minus 4. The plus 5 vanishes upon differentiation. Now the 3 with the 3 will cancel out, the 2 with the 2 will cancel out. So all in all, we get that the y dx is equal to 2x squared minus 7x minus 4. Now in part B, we're asked to hence find the range of values of x for which y is decreasing. Well, we know that if y is decreasing, this means that the y dx is less than or equal to 0. So we're being asked to solve the inequality 2x squared minus 7x minus 4 being less than or equal to 0. Please note that this could be a strict inequality and both of them are acceptable. I will now proceed in factorizing the left-hand side into 2x plus 1, the first bracket, x minus 4, the second bracket being less than or equal to 0. And I will proceed in finding the critical values, which are those values of x that will make the left-hand side 0. So we're looking at 2x plus 1 is 0 and x minus 4 is 0, leading to 2x is negative 1, which means that x is minus a half or x is 4. These are the two critical values, and I can proceed into plotting them on a smiley-shaped parabola. It looks something like this. We go plus, then minus, plus. We can see that the inequality has to be less than or equal to 0, so we want the negative part, which is the in-between part, and therefore we conclude that we want minus a half being less than or equal to x being less than or equal to 4. If you decide to go with strict inequalities, both of them should be strict and you will still be qualifying for full marks. In question 2, we must show all stages of our working and solutions relying on calculator technology are not acceptable. So we are asked to use the substitution u is root x or otherwise to solve this equation here. This is what we call a disguised quadratic. So I'll be using u is root x. Notice that u is greater than or equal to 0 because when I refer to the square root of a number, I always refer to the positive square root. Now the first thing to do is realize that u squared is equal to x. So essentially I'm performing a substitution. In the place of x, I'll be putting u squared. So we're looking at 6u squared plus 7u minus 20 is equal to 0. Now this factorizes into 2u plus 5 times 3u minus 4. So we're looking at 2u plus 5 being equal to 0, or alternatively 3u minus 4 being 0, which means that 2u is negative 5, and therefore u is negative 5 over 2, which is rejected because we said that u has to be greater than or equal to 0, or alternatively 3u is equal to 4, which means that u is 4 over 3. Now recall that u is root x, so we've got root x is 4 over 3. So x is 4 over 3 squared, which means that x is 16 over 9. Alternatively, I could have avoided completely the advice of using the substitution u is root x. So what I could have done is isolate the root x term. So we're looking at 7 root x being 20 minus 6x. I will now square both sides. So we're looking at 7 root x squared being equal to 20 minus 6x all squared. So we've got 49x being equal to 400 minus 240x plus 36x squared, leading to 0 being 36x squared minus 289x plus 400. Now I can factorize this, or I can use a quadratic formula to find the solutions for x. Anyway, it factorizes into 9x minus 16 times 4x minus 25, which means we've got 9x minus 16 is equal to 0, or alternatively 4x minus 25 is 0. So we're looking at 9x is 16, which means that x is 16 over 9, or 4x is 25, which means that x is 25/4. Now at the moment we've got two candidate solutions for the given equation here, so I'm gonna go on my calculator to check that both of these solutions are indeed valid. So what I'm gonna do 16/9. I will store it on my answer key, and I'll do 6 times ans plus 7 root of ans minus 20. If I get the result of 0, this means that this is a valid answer. I press the equal sign. I got the 0, perfect. 16/9 is correct, which agrees with the solution we found before with the substitution of u being root x. Let's try 25/4. So I'm going to do 25/4. I press the equal sign. I've stored it on my answer key. I'm going to press the up button to get the previous expression. I press the equal sign, and this will evaluate this with the new answer key holding the value of 25/4. I get an answer of 35, which is not 0. So I have to say reject here. It's not valid. And therefore, all in all, we conclude that the only solution to the given equation is x being 16/9. In question 3, we've got a sketch showing the position of 3 phone masts, that's A, B, and C. They are identical and their bases are assumed to lie in the same horizontal plane. Now mast A is 8.2 kilometers from C on a bearing of 072, and mast B is 15.6 kilometers from C on a bearing of 039, and we need to work out the distance between A and B, giving our answer in kilometers to 1 decimal place. So let me start by adding the information on the diagram here. We've got that the distance AC is 8.2 kilometers. Now the bearing is measured from the north and moving clockwise, so that's 72 degrees. And then the distance from B is 15.6 and the angle is 39 degrees, which means I can close A and B together to see the triangle form. And obviously the angle here should be 72 minus 39, which is 33 degrees. And therefore I can proceed with the cosine rule. We've got AB squared being equal to 8.2 squared plus 15.6 squared minus 2 times 8.2 times 15.6 cosine of 33. If I evaluate this on my calculator, I get that AB squared is 96.0345 ... And if I take the square root of this, I get 9.7997 ... which to the nearest dp is 9.8 kilometers. Now an engineer needs to travel from A to B, and we need to give a reason why the answer we just obtained, the 9.8 kilometers, is unlikely to be an accurate value for the distance the engineer travels from A to B. Now in these kind of questions, we always go back to the text. If you read carefully, it says that we are assuming the bases are lying in the same horizontal plane. So the first thing we could say is that the bases of the masts are unlikely to be lying on horizontal ground. Another explanation which is accepted is that we could say that it is unlikely for the route from A to B to be a straight line. In 4a, we are asked to sketch the curve with the equation y is k over x, where k is a positive constant, so we surely know we're looking at a reciprocal curve. So since k is positive, then we are in the first and third quadrants, so this is the curve with the equation y is k over x. In part B, we are asked to hence or otherwise solve 16 over x being less than or equal to 2. I'll be using the sketch we have just drawn. K is now 16. I will draw a horizontal line. There it is. It's the line with equation y is equal to 2. I want to find the values of x, the range of values of x for which my curve, the 16 over x, is below the straight line. The horizontal line y is 2, which is this region here and this region here. So the first thing to do is find the point of intersection over here. So I will start by equating 16 over x with 2, leading to 16 is equal to 2x, and therefore x is equal to 8. So this is 8 here, so I surely need this part here and then this part here. So we want to be on the left hand side of the y-axis, so we want x to be less than 0, or we want x to be greater than or equal to 8. Be careful here, we cannot include 0 in our solution set because this is not defined for x is 0. X is 0 is an asymptote, but for 8 this is included because this was a relaxed inequality. Now, because the question says hence or otherwise, there is an alternative algebraic approach that does not depend on the diagram here. So starting with 16 over x being less than or equal to 2, it would be wrong to cross multiply by x because we don't know whether x is positive or negative, and therefore we don't know whether the direction of the inequality is affected. So to avoid this, I will multiply both sides of the inequality by x squared, taking me to 16x being less than or equal to 2x squared, and therefore 0 is less than or equal to 2x squared minus 16x. I will factor out the 2x, so it's 2x brackets x minus 8, and therefore I can extract the two critical values for this inequality here. It's either x is 0 or x minus 8 being 0, so x is 8, and I can therefore proceed in illustrating this on a parabola. As shown here, we've got 0, we've got 8, we go plus, minus, plus. We want to be positive 2x times x minus 8 to be greater than or equal to 0. I am tempted in saying x less than or equal to 0 or x greater than or equal to 8. However, again, because x being 0 is a problematic value, it's the asymptote, the 16 over x is not defined for x is 0. I need to exclude this, so I need to erase this. That would be the correct answer if I was to follow the algebraic approach. I'm sure you would agree that working with the diagram is a lot easier because you can see exactly what's happening here. In question 5, we are told to show all stages of the working, and solutions relying on calculator technology are not acceptable. Well, we are given the finite region R, shown shaded here. It is bounded by the curve with the equation y is 4x squared plus 3, the y-axis, and the line with the equation y is 23. And we need to show that the exact area of R is k root 5, where k is a rational constant to be found for 5 marks. I will start by finding the x-coordinate of the point here. So I'll be substituting y is 23, which means that we are looking at 4x squared plus 3 is 23. So 4x squared is equal to 20, meaning that x squared is 5, and therefore x is root 5. I'm taking the positive square root because I can see that the x-coordinate of the point I'm after is positive. So I will start by marking on my diagram the root 5. There it is. We are trying to determine the shaded area R, and I can see this as a rectangle minus the area under the curve between x is 0 and x is root 5, and this will be found by using integration. So the shaded region R is the area of the rectangle, which is the height of 23 times the base of root 5, minus the integral from 0 up to root 5 of 4x squared plus 3 dx. So we're looking at 23 root 5 minus 4x cubed over 3 plus 3x, and the limits are 0 and root 5. I will proceed in substituting the upper limit and then the lower limit. So we've got 23 root 5 minus 4 times root 5 to the power of 3 over 3 plus 3 root 5. And we can notice that when I substitute the lower limit of 0, both of these are 0, so there is an overall contribution of 0 from the lower limit. I will proceed in simplifying, so we've got 23 root 5 minus, I will factor out the root 5 here to make the calculation easier. So if I take the root 5, I'm left within the brackets with 4 times root 5 squared over 3 plus 3. So I can evaluate the bracket. It's 23 root 5 minus root 5, and I've got 4 times 5 over 3 plus 3 within the bracket here, which means we're looking at 23 root 5 minus 29 over 3 root 5. I can express everything as a single term, we are looking at 40 over 3 root 5 units squared for the area R. In question 6, we're given the equation of a circle C where k is a constant, and we're asked to find the coordinates of the center of C. Well, we know that for a circle centered at the point alpha beta with a radius of r, then the equation is x minus alpha squared plus y minus beta squared is equal to r squared. So the idea is to take this equation here, complete the square for both x squared and y squared in order to put it in the standard form. So we've got x squared minus 6x, which I can complete the square as x minus 3 squared minus 3 squared. We then have the y squared plus 10y, so we've got y plus 5 squared minus 5 squared plus k is equal to 0. So we're looking at x minus 3 squared minus 9 plus y plus 5 squared minus 25 plus k is equal to 0. And therefore we have x minus 3 squared plus y plus 5 squared minus 34 plus k is equal to 0, which leads to x minus 3 squared plus y plus 5 squared is equal to 34 minus k. This matches exactly the standard form here, and we can see that the center of this circle has coordinates 3, negative 5. Now in part B, we are told that C does not cut or touch the x-axis, and we need to find the range of possible values for k. Well, it makes sense to draw a quick diagram to see what's happening. We've got the axis here, we've got the circle which is centered at 3, negative 5. Now obviously this is the radius here r, and now the distance of the center from the x-axis, this distance here is 5 units because the y-coordinate of the center is negative 5. Now we want this circle not to be touching or cutting the x-axis, so essentially we need the radius r to be less than 5. And if we look at the equation we arrived at in part A, the radius is the square root of 34 minus k. So we need 34 minus k under a square root to be less than 5. So we want 34 minus k to be less than 25, which leads to 9 being less than k. But that's not the end of the story. Be careful here. R is a distance, it's the radius, so this means that the square root of 34 minus k should be a valid answer. It means that 34 minus k should be positive. Otherwise, when I take the square root of this, I'll be taking the square root of a negative, which on the calculator will give a math error. So I'm going to say that we also need the 34 minus k to be greater than 0, which means 34 is greater than k. So all in all, we've got 9 being less than k being less than 34. In question 7, we've got the distance a particular car can travel in a journey starting with a full tank of fuel being investigated. Now we are told that from a full tank of fuel, 40 liters remained after a car had traveled 80 kilometers, while 25 liters remain when the car traveled a distance of 200 kilometers, and we need to use a linear model with capital V liters being the volume of fuel remaining in the tank and d kilometers being the distance that we have traveled, and we need to find an equation linking V with d. Now since we are talking about a linear model, this would be a model of the form V is AD plus B, where A and B are constants to be determined. Well, we know that when the distance is 80, then capital V, the volume remaining is 40. So this means we're looking at 40 being equal to 80A plus B. And when D is equal to 200, we get that capital V is 25, which means that 25 is equal to 200A plus B. So I'm solving simultaneous equations here. I can deduct one from the other. So 40 minus 25 is 15, which is equal to 80A minus 200A, which is minus 120A and the b is eliminated. So we're looking at minus 1 over 8 being the value of a, and I can proceed in finding the value of b. I will substitute into the first equation here. So we've got 40 is equal to 80 times the value of a, which is minus 1 over 8 plus b. So 40 is minus 10 plus b, which means that 50 is equal to b. And therefore, to conclude, the equation linking v with d, which is what we were asked to do here, is capital V is minus 1 over 8d plus 50. Now, alternatively, I could have treated this as a straight line equation from the onset. So we've got 2 points. We've got the point 80, 40, and the second point was 200, 25. I will start by finding the gradient. So the gradient is defined to be y2 minus y1 over x2 minus x1. So we're looking at 25 minus 40 over the 200 minus 80, which gives an answer of minus 1 over 8. And then I will proceed with the equation of a straight line. Y minus y1 is mx minus x1. So my y is actually capital V. I need to adjust to the new variables, the new letters. Minus 40 is equal to minus 1 over 8, and my x is the d, minus 80. So we're looking at v minus 40 is minus 1 over 8d plus 10, which of course gives the same answer that we have just obtained. Capital V is minus 1 over 8d plus 50. Now, given that on a particular journey the fuel tank was initially full and the car continued until it ran out of fuel, we need to find, according to the model, the initial volume of fuel as well as the distance that the car traveled. So we've got the equation that links V with D here. So for the first part, the initial volume is found by setting D is 0. And this means that we're looking at V is equal to 50. And I need to include the units here. So we're looking at 50 liters. And to find the distance that the car traveled on this journey, well, we know that the car continued until it ran out of fuel. This means that we need to set capital V to be 0. So setting capital V to be 0 means that we're looking at 0 is minus 1 over 8d plus 50, leading to 1 over 8d is equal to 50. And therefore, d, the distance covered, is 400, and this is kilometers. Now, in fact, the car traveled 320 kilometers on this journey, and we need to evaluate the model in light of this information. Well, we have found 400, but actually it was 320. So we need to say that 320 is significantly less than the 400, and therefore the model is not valid. Now, the key word here is the significantly. If you do not include the word significant, then you are not scoring the mark, because it's not enough for you to say that 320 is less than 400. You need to mention that they differ by a significant amount, and therefore this makes the model invalid. In question 8, we are given a sketch of the curve C shown here in the straight line L. We are told that the equation of C is f of x, where f of x is a quadratic expression in x. Additionally, we can see that we are cutting the x-axis at 0 and 6, and then the line L is cutting the y-axis at 60, and it's intersecting C at the point 10, 80. And we need to use inequalities to define the region R, shown shaded in figure 3. Well, I will start by considering the equation for the curve C. So f of x, we know it's a quadratic expression in x. Using the fact that we've got cuts on the x-axis at 0 and 6, we know that the factorized form for f of x will be x times x minus 6. And in addition, there might be a constant k here that I need to determine. So this particular form ensures that we are cutting the x-axis at 0 and 6. And then I will use the fact that we pass through the point 10, 80 to determine the value of the constant k. So we've got f of 10 being equal to 80, which means that 80 is equal to k times 10 times 10 minus 6. This leads to 80 is equal to 40k, and therefore k is equal to 2, and we conclude that f of x is 2x times x minus 6. Now for the straight line L, I will start by calculating the gradient. I'm doing rise over run, so y2 minus y1 over x2 minus x1, which gives an answer of 2. So my straight line has a gradient of 2. We can see that we are cutting the y-axis at 60. This means that the y-intercept C is equal to 60, and therefore the equation of the straight line is y is 2x plus 60. And looking at the shaded region, we want to be below the straight line and above the parabola here. So we want y to be less than the 2x plus 60. I can put relaxed inequalities here, so less than or equal to 2x plus 60. And we've got y being greater than or equal to 2x times x minus 6, so above the parabola, which can be put together as 2x times x minus 6 being less than or equal to y, which is less than or equal to 2x plus 60. Now, if you decide to go with strict inequalities, that's okay, but you need to be consistent. So you'll have y less than 2x plus 60 and y greater than 2x times x minus 6, and that will be perfectly fine. Now, for determining the equation of C, there is another way you can do this. So you could start by saying, since this is a quadratic expression in x, then we've got f of x is alpha x squared plus beta x plus gamma, for alpha, beta, and gamma being constants to be determined. Well, we know that we pass through the origin, so f of 0 is 0, which means that 0 is equal to gamma, so we've just found gamma. And then we also have that f of 6 is equal to 0, which means that 0 is alpha times 6 squared plus 6 beta, the gamma is 0. So this leads to 0 is 36 alpha plus 6 beta, and I can divide throughout by 6 to get 0 is 6 alpha plus beta. And then I'm using the fact that we pass through 1080, so f of 10 is equal to 80, which means that 80 is equal to alpha times 10 squared plus 10 beta, leading to 80 being equal to 100 alpha plus 10 beta. Now we'll divide throughout by 10 to get that 8 is equal to 10 alpha plus beta. And I can combine the two equations here in alpha and beta to eliminate beta. So if I deduct one from the other, 0 minus 8 is negative 8, and 6 alpha minus 10 alpha is minus 4 alpha, and the beta vanishes. So we get that 2 is equal to alpha. So 0 is 6 times alpha plus beta. So 0 is 12 plus beta, which means that negative 12 is the value of beta. And we get that f of x is equal to 2x squared minus 12x, which is simply the expanded form of 2x brackets x minus 6. And that would be an alternative way of determining the quadratic expression corresponding to f of x. In question 9, we are asked to use the laws of logarithms to solve the given logarithmic equation here. So I will start by trying to get all the terms on the left-hand side into a single logarithmic term. The first thing to do is take the 2 up as a power. So we're looking at log of 3x minus 2 raised to the power of 2 base 5 minus log of x base 5 being equal to 2. Now we know that when we've got subtraction of two logs, then this is the log of the quotient. So we're looking at log of 3x minus 2 squared over x base 5, which is equal to 2. And then I will open up the log by saying that 3x minus 2 squared over x is equal to 5 to the power of 2. So I will expand the left-hand side. We've got 9x squared minus 12x plus 4 over x being equal to 25, leading to 9x squared minus 12x plus 4 being equal to 25x. I will collect everything on the left-hand side, leading to 9x squared minus 37x plus 4 is equal to 0. and I will proceed by factorizing. We've got 9x minus 1 times x minus 4 being equal to 0, which means that 9x minus 1 is 0, or alternatively x minus 4 is 0. So we've got 9x is 1, which means that x is 1 over 9, or x is equal to 4. Now, at the moment, we've got two candidate solutions for the given logarithmic equation, but we need to go back to the original equation. We had the log of 3x minus 2 and the log of x, and we know that the argument of the logarithm here should always be positive, so we need both of these to be positive. So we need the 3x minus 2 to be positive, and we also need the x to be positive. So we need 3x to be greater than 2, which means x is greater than 2 over 3, as well as x being greater than 0. Now, both of these inequalities are satisfied when x is greater than 2 over 3. So looking at the two solutions we obtained from the quadratic, 1 over 9 is not within the solution set, so I need to reject this. I say it's not valid, and therefore we conclude that there is only one solution, and this solution is x is equal to 4. In question 10, we are told that the line L1 has equation y is 3 over 5x plus 6. This is the line L1, and the line L2 is perpendicular to L1, passing through the point B with coordinates 8, 0. And we need to show that an equation for L2 is 5x plus 3y is 40. Well, let me start by noting that B has coordinates 8, 0. Well, we know that the gradient of L1 is simply 3 over 5 because the equation of L1 is of the standard form y is mx plus c. And I can infer the gradient of L2 by the fact that the two lines are perpendicular, and we know that the two gradients need to multiply out to -1. So what I do, I flip the gradient and I change the sign. So the gradient of L2 is minus 5 over 3. And using y minus y1 is mx minus x1, I can proceed in finding the equation of L2. So we're looking at y minus 0 being equal to minus 5 over 3 brackets x minus 8. I will cross multiply, so get 3y, and I expand the right hand side to get minus 5x plus 40, which leads to 3y plus 5x is equal to 40 as required. Now, given that the lines L1 and L2 intersect at the point C and line L1 is crossing the x-axis at the point A, we need to find the exact area of triangle ABC, giving our answer as a fully simplified fraction in the form P over Q. So this is the diagram we had. We've got the equations of the straight lines L1 and L2 respectively, and we need to find the area of triangle ABC, which is what I've shaded here. I will start by finding the coordinates of point A. So we know that at point A, y is equal to 0, which means that 0 is 3 over 5x plus 6, which takes me to -6 being 3 over 5x. So minus 30 is equal to 3x, and therefore -10 is the x coordinate of the point A. I'm going to write this on my diagram so that I've got all the information on the diagram. And the idea here is that we now have the base of the triangle, which is simply 10 plus 8. So the base is 18. If I find the y coordinate of point C, that will be the height of the triangle, and I'll be able to proceed with base times height over 2. So C is the point of intersection between the two lines, so I'm equating the two. So I will be substituting y with 3 over 5x plus 6. So we've got 5x plus 3 times 3 over 5x plus 6 being equal to 40. I will proceed by expanding the brackets to get 5x plus 9x over 5 plus 18 is equal to 40. And then I will multiply throughout by 5 to get 25x plus 9x plus 90 being equal to 200, which leads to 34x being equal to 110, and therefore x is 55 over 17. Remember, I'm trying to find the y coordinate of point C. So we know that y is equal to 3 over 5x, which was found to be 55 over 17, and then plus 6, which gives an answer of 135 over 17. So going on the diagram here, the y coordinate of C is the height of the triangle, which is 135 over 17, and therefore we know that to find the area of the triangle ABC, I'll be multiplying base with height and dividing by 2. Now the base is 10 plus 8, the height is 135 over 17, and I divide by 2. This gives an answer of 1215 over 17 units squared for the area of the triangle. In question 11, we are told that the height h meters of a plant t years after being first measured is modeled through this equation here, and we need to use the model to find the height of the plant when it was first measured. So obviously I will be substituting t is equal to 0 to find the initial height. So h is 2.3 minus 1.7 e to the 0. Now e to the 0 is simply 1. 2.3 minus 1.7 is 0.6, and we are talking about meters. You need to include the units because we are looking at the model in context. So the height of the plant when it was first measured was 0.6 meters. In part B, we need to show that exactly 4 years after first being measured, the plant is growing at a rate of approximately 15.3 centimeters per year. So we need to be looking at the rate of change of the height with respect to time. So we're differentiating. The 2.3 is a constant, so the derivative is 0. And then we've got minus 1.7. When I'm differentiating an expression with e, I get the derivative of the exponent down, which is negative 0.2, and it's e to the minus 0.2t, which simplifies to 0.34 e to the minus 0.2t. Now I need to proceed in evaluating this. The derivative at t is equal to 4 because we're looking at 4 years after first being measured. So it's going to be 0.34 e to the minus 0.2 times 4. If I plug this on the calculator, I get 0.1527 ... which is meters per year. It's a show that question. We need to arrive at 15.3 centimeters per year. So I need to give more accuracy before arriving at the final answer. So from meters to centimeters, I multiply by 100, and we can see that this is 15.3 centimeters per year as required. Now, according to the model, there's a limit to the height to which this plant can grow, and we need to deduce the value of this limit. So the equation of the model was h is 2.3 minus 1.7 e to the negative 0.2t. The limit will be found by considering the behavior of h as t tends to infinity. So as t tends to infinity, the exponential term will die out. It tends to 0 because the exponent will be very large and negative, and therefore h tends to 2.3. Now, we cannot do this limiting process if we are not familiar with the fact that e to the minus 0.2t will tend to 0. As an alternative, I can go on my calculator. I'll put a really big number on my answer key, and then I'm going to do 2.3 minus 1.7 e to the minus 0.2 ans. So I'm mimicking the behavior of h as t grows larger and larger. So it tends to 2.3, and therefore we conclude that the value of this limit is going to be 2.3 meters. In question 12, we are asked to show detailed working, and solutions relying entirely on calculator technology are not acceptable. So we've got the equation 4 tan x is 5 cos x, and we need to show that this can be written as a quadratic in sign. So we start by writing tan x as sine x over cos x. So we've got 4 sine x over cos x being equal to 5 cos x. I will proceed by cross multiplying to get 4 sine x being equal to 5 cos squared x. and we know that sine squared plus cos squared is 1. So we've got 5 times 1 minus sine squared x on the right hand side, which leads to 4 sine x being equal to 5 minus 5 sine squared x. I will be collecting everything on the left hand side, which leads to 5 sine squared x plus 4 sine x minus 5 being equal to 0 as required. In part B, we're asked to hence solve for x between 0 and 360 the given trigonometric equation, giving our answers to one decimal place. So we've got a quadratic, the coefficient of sine squared is 5, the coefficient of sine is 4, and the constant term is negative 5. So I'll be using the quadratic formula, so sine x is minus b plus minus b squared minus 4ac square rooted, and all of it divided by 2 times a, so 2 times 5. If we plug this on the calculator, we get that sine x is negative 2 plus root 29, and all of it divided by 5, which numerically is 0.677 ... Or alternatively, we've got that sine x is minus 2 minus root 29 over 5, which is equal to negative 1.477. Well, knowing that sine x varies between negative 1 and 1, we know that this solution here will not yield any values for x. So I would say reject here, not valid, and I will proceed in solving sine x being 0.677. I will start by finding the principal value, which is shift sine of the 0.677 ... which gives an answer of 42.612 ... And since I'm dealing with sine x, we know that one solution for x will be 42.612 ... plus 360k, whereas a second solution will come out of x being 180 minus 42.612 ... plus 360k. Well, x varies between 0 and 360, so we've got a total of 2 solutions between 0 and 360. It's x being 42.6 or 137.4. And then in part C, we're asked to hence find the number of solutions to the equation 4 tan 3x is 5 cos 3x in the interval 0 to 1800, explaining briefly the reason for our answer. Well, first of all, the 3x means that we are squeezing the graphs by a scale factor of 3, and this means we are tripling the number of solutions. In addition, we've got a new interval here. The interval width was originally 360, it is now 1800, so we have multiplied this width by a scale factor of 5, and therefore we've got 2 solutions in the original equation times 3 because of the squeezing by the scale factor of 3, times 5 because we've got a larger interval leading to a total of 30 solutions. Question 13 is on vectors. We've got the point A with position vector 10i minus 3j, and then the position vector for points B and C, and we need to find the vector AB. Well, we know that the vector AB is going to be the position vector of point B, which is negative 8, 9, minus the position vector of point A, which is 10, negative 3. It's always the second letter minus the first. So minus 8 minus 10 is minus 18, and 9 minus negative 3 is 12. So this gives an answer of minus 18i plus 12j. We're then asked to find the magnitude of the vector AB, giving our answer as a fully simplified surd. So we know that to find the magnitude of a vector, I will take the I component and square it. Then I will take the j component and square it, add them up and take the square root. So it's essentially Pythagoras theorem here, and this gives an answer of 6 root 13. Now, given that points A, B, and C lie on a straight line, we need to find the value of P and state the ratio of the area of triangle AOC to the area of the triangle AOB. So, looking at the position vectors for A, B, and C, and in particular the I components, we can see that the negative to the I component of point C is sitting between the I components of A and B, and this means that if I draw a straight line, then we expect C to lie between A and B as shown here. In addition, I will put the origin somewhere. I'll be joining A with O, C with O, and B with O. And we've got two triangles. It's triangle AOC, shown shaded here, and then triangle AOB, which is the big triangle here. So we are trying to find the ratio of the area of triangle AOC to the area of the triangle AOB, and also we need to find the value of P. So let's start with what we know. We know that the vector AB is negative 18, 12, and then I can proceed to find the vector AC. Now the vector AC is gonna be the position vector of C, which is negative 2P, minus the position vector of A, which is 10, negative 3. So negative 2 minus 10 is negative 12, and P minus negative 3 is P plus 3. And we know that since ACB lie on a straight line, then it must be the case that AB and AC are parallel. So vector AB is parallel to the vector AC, which means that negative 18, 12 is parallel to negative 12 P plus 3, and therefore I can look at the ratio of the components. So we've got negative 18 over 12 being equal to negative 12 over P plus 3. I will proceed by cross multiplying, so we've got minus 18 times P plus 3 being equal to negative 144. So minus 18P minus 54 is negative 144, leading to 90 being equal to 18P, and therefore P is equal to 5. Now to find the ratio of the area of the triangle AOC to the area of the triangle AOB, we will start by finding the magnitude of the vector AC. It was negative 12P plus 3, and P was found to be 5. So for the magnitude of the vector AC, we will be doing the magnitude of the vector negative 12, 8. So it's going to be negative 12 squared plus 8 squared and all square rooted, which gives an answer of 4 root 13. So going to our diagram here, AC is 4 root 13, whereas AB was found to be 6 root 13. We can see that both triangle AOC and triangle AOB have the same height, and the only thing that changes is the base. So the base of AOC is 4 root 13, whereas the base of AOB is 6 root 13, and therefore the ratio of the areas will be exactly the ratio of the bases, simply because the height remains the same. So for triangle AOC to triangle AOB, the ratio is going to be 4 to 6, which simplifies to 2 to 3. In question 14, we're asked to find in its simplest form the coefficient of x to the power of 5 in the expansion of this expression here. Now, obviously, we're looking at the binomial expansion. We're only interested in the coefficient of x to the power of 5, so no need to do the full expansion here. We need to consider which terms or which combination of terms will give me an x to the 5 term. And it's going to be the constant times the term in x to the power of 5, and then the x squared term times the x cubed term. So let's start. We've got the 5 plus 8x squared, and I'll be applying the binomial expansion. I'm only interested in the x cubed and x to the 5 terms. So we've got dot 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 plus 6, choose 3, and we've got 3 to the power of 3 and minus a half x to the power of 3. Remember that the two indices should always add up to the original power, which is 6. And then for the x to the 5 term, we've got 6, choose 5, we've got 3 to the power of 1, and minus a half x to the power of 5 plus dot dot dot. Let me proceed by simplifying. So it's 5 plus 8x squared times dot 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 minus 135 over 2x cubed minus 9 over 16 x to the 5 plus dot dot dot. Remember, we're trying to find the overall x to the 5 term here, so it's gonna be the constant times x to the 5 and the x squared times x cubed, leading to 5 times the minus 9 over 16 x to the 5 plus 8x squared times minus 135 over 2x cubed plus dot dot dot. Now this is giving me minus 45 over 16 x to the 5 minus 540 x to the 5 plus dot dot dot, which if I combine together will give me minus 8,685 over 16 x to the 5 plus dot dot dot. And therefore we conclude that the coefficient of x to the 5 is minus 8685 over 16. Now be careful here, the question is asking for the coefficient. If you stop here, you will be penalized. You just need to report the number with the sign in front of x to the 5, because this is exactly the coefficient of x to the power of 5. In question 15, we're asked to show detailed reasoning and solutions relying on calculator technology are not acceptable, so I need to be showing my work clearly here. So we've got two curves and we need to verify that when x is 1, the two curves intersect. Now the prompt to verify means that we just need to check that when x is 1, it is indeed the case that the two curves intersect. It's not a matter of me finding that x is 1, I just need to confirm that it's indeed the case that x is 1. So I will start by saying that when x is equal to 1, we've got that y is 8 minus 10 times 1 plus 6 times 1 squared minus 1 cubed, which gives an answer of 3. Whereas for the second curve C2, y is 1 squared minus 12 times 1 plus 14, which also gives an answer of 3. And therefore we can safely conclude that the two curves intersect when x is 1. We're then told that the curves also intersect when x is k, where k is a negative number, and we need to use algebra to find the exact value of k. Well, I will start by equating the two curves. So we've got 8 minus 10x plus 6x squared minus x cubed being equal to x squared minus 12x plus 14. I will be collecting everything on the right hand side, which means that 0 is x cubed minus 5x squared minus 2x plus 6. Now we know that x is 1 is a solution to this equation. This is a cubic equation. We don't have a cubic formula. We cannot use our calculator to simply extract the answers. But knowing that x is 1 is a solution means that x minus 1 is a factor, and therefore I can proceed with the long division. So x will be multiplied by x squared to get x cubed, and I've got a minus x squared as well, and I deduct. Then the x cubed with the x cubed cancel out, and the negative 5x squared minus negative x squared will give me minus 4x squared, and I get the negative 2x plus 6 down as well, minus 4x leading to minus 4x squared plus 4x, and I deduct once more, leading to minus 6x plus 6. So I've got a minus 6 here, so we've got minus 6x plus 6, leaving me with a remainder of 0 as expected. So all in all, we have managed to factorize the cubic into the product of x minus 1 and x squared minus 4x minus 6. Now obviously we've got x minus 1 is 0, which means that x is 1, which is not the point we are after. Or alternatively, we've got x squared minus 4x minus 6 is 0. and I'll be using the quadratic formula to proceed. We've got x is negative minus 4 plus minus negative 4 squared minus 4 times 1 times negative 6 square rooted, and all divided by 2 times 1. This gives answers for x of 2 plus minus root 10. But remember, we've been told that k is negative, so all I have to do is say that since k is known to be negative, then this means that k is 2 minus root 10. Remember, your final answer should be in terms of k. Don't say x is 2 minus root 10. We are talking about k, so k is equal to 2 minus root 10. In question 16, we've got a curve with equation y is f of x. We are given the expression corresponding to the derivative f dash of x in terms of constants a and b. Additionally, we are told that we've got a stationary point at 4, 3, and we are meeting the y-axis at negative 5, and we need to find f of x, giving our answer in its simplest form. Well, let me start by the fact that we've got a stationary point at x is 4. This means that f dash of 4 is equal to 0, because we know that stationary points satisfy that the first derivative is 0. This leads to 4 times 4 plus a times root 4 plus b is equal to 0, and therefore we've got 16 plus 2a plus b is equal to 0. I then proceed with f dash of x, which we have been told is 4x plus ax to the half plus b. Well, I will integrate to get an expression for f of x. So f of x is going to be the integral of 4x plus ax to the half plus b dx, and this gives 4x squared over 2 plus ax to the 3 over 2 over 3 over 2. I increase the power by 1 and divide by the new power. The b, when integrated, will give me bx, and I've got the c, the constant of integration. And knowing that the curve meets the y-axis at negative 5, this means that f of 0 is negative 5, because the cut on the y-axis means that x is 0, leading to negative 5 being equal to c, because all of these terms will be 0 when I substitute x is 0. So we have established that c is negative 5. Now we've got one equation in a and b. I need to find another equation in a and b, and I'll be using the fact that the point 4, 3 is a point on the curve. This means that f of 4 is equal to 3, and therefore we are looking at 4 times 4 squared over 2 plus 2a times 4 to the 3 over 2 over 3 plus 4b plus the c, which is negative 5, is equal to 3. This leads to 32 plus 16a over 3 plus 4b minus 5 is equal to 3. And therefore, we get that 27 plus 16a over 3 plus 4b is equal to 3. Well, I will collect everything on the left-hand side, so we get 16a over 3 plus 4b plus 24 is equal to 0. I will now multiply throughout by 3 to get 16a plus 12b plus 72 is equal to 0. And I'll divide everything by 4 to get 4a plus 3b plus 18 is equal to 0. So we're dealing with simultaneous equations in a and b. This was the second equation, and this is the first equation. I will multiply this first equation by 2 to get 4a plus 2b plus 32 is equal to 0. And if I deduct one from the other, I get that b minus 14 is equal to 0, and therefore we arrive at b is equal to 14. I will now proceed in finding the value of a. So we've got 0 is 2a plus b plus 16. So we get that 0 is 2a plus 30. Negative 30 is 2a, which means that a is negative 15. And I can now proceed in stating that f of x is 2x squared plus 2 times the a of negative 15, x to the 3 over 2 over 3, plus the b, which is 14x minus 5, and all of this simplifies to 2x squared minus 10x to the 3 over 2 plus 14x minus 5. In question 17, we are told that we've got p and q positive integers with q being greater than p, and statement 1 says that q cubed minus p cubed is never a multiple of 5, and we need to provide a counter example to show that this statement is not true. Now, with a counter example, we mean a particular specific example with numerical values for both q and p that will show that this statement is not true. So if the statement is saying that this is never a multiple of 5, then it will be enough to provide values that will give me an overall result which is a multiple of 5. So I'm thinking of both q and p being multiples of 5. So I consider 10 cubed minus 5 cubed, which is 1,000 minus 125, which is equal to 875, which is of course a multiple of 5. It is 5 times 175, and therefore we conclude that the statement here is not true. Now, statement 2 says that when p and q are consecutive even integers, then q cubed minus p cubed is a multiple of 8, and we need to prove this statement using algebra. So I will start by considering p to be 2n and q to be 2n plus 2. So if p is 2n, then it's surely an even integer, and 2n plus 2 is the next even integer. So we can proceed in considering now q cubed minus p cubed, which is 2n plus 2 raised to the power of 3 minus 2n raised to the power of 3. So we're looking at 2n raised to the power of 3 plus 3 times the 2n squared times 2. So I'm applying the binomial expansion to expand the cubic brackets, plus 3 times 2n times 2 squared plus 2 cubed minus 8n cubed. This gives an answer of 8n cubed plus 24n squared plus 24n plus 8 minus 8n cubed. We notice that the 8n cubed will cancel out, and therefore I can factor out the 8, leading to 8 times 3n squared plus 3n plus 1, which is a multiple of 8, and therefore we conclude that statement 2 is true. Now be careful here, we are looking at a prove that question, so we need to end up with a conclusion in order to get all 4 marks.